So these are the numericals which we are going to do. These are from chapter 1, unit 4, electric current numericals. So all these numericals we will do. You may take the screenshot. So first we will do the concept behind these numericals. These are based on parallel and series combination of the circuits and current in a circuit, electric current in a circuit. So we will do all these numericals. So first we will do the concept. First we will do concept behind all. So very first concept is concept of EMF. What is EMF of a battery? EMF is equal to the total potential drop in a circuit. Total potential drop in a circuit. Then we have Ohm's law. It states potential drop is equal to current into resistance in a circuit. V is equal to I into R. Then we have series combination. And we have parallel combination. So in series combination, the resistances are in series. All the resistances are in series. What does resistances in series mean? Resistances in series means that suppose current I is equal to 2 ampere is coming from the cell, then the same current 2 ampere will flow from each of the following resistances. From each of the following resistances, same current will flow, but potential difference across each will be different. Here it will be V1, here it will be V2, V3. Potential difference across every resistance will be different. It will be equal to current times the resistance. So V1 will be equal to I into R1, V2 will be equal to I into R2, and V3 will be equal to I into R3. This will be the total resistance, and then we have to find the total resistance, equivalent resistance of this circuit. Equivalent resistance means in spite of these three resistances, if we use only one resistance, then what will be the value of that resistance? So we know that if this is the EMF of the cell is, EMF is equal to V, we know that V1 plus V2 plus V3 will be equal to the total resistance. We know will be equal to total potential. V1 plus V2 plus V3 will be the total potential. Therefore, V1 is I into R1 plus I into R2 plus I into R3 will be equal to I into R equivalent. So I is common in all, so I will get cancelled. So here R equivalent will come out to be R1 plus R2 plus R3. Therefore, in a series combination, equivalent resistance is the sum of the three resistances. Now there is a parallel combination. What do you mean by a parallel combination of resistances? Suppose we have the three resistances R1, R2 and R3, and we have a cell of EMF is equal to V. Then suppose from here current I is coming. Current I is equal to, suppose 3 ampere is coming from this cell. Then the same current will not flow from all the cell. After coming here, there are 3 branches. The circuit has been divided into 3 branches. First branch have the resistance R1, second have the resistance R2, and third have the resistance R3. So current will be divided. So I1 current will flow here, I2 will flow here, and I3 current will flow in the third circuit. But here, because the both the ends of all the resistances, so and first and 1 and 2, 3, 4, 5 and 6, all the ends are directly connected with the point A and B, and point A and B is directly connected with the terminals of the cell. Therefore potential difference across each resistance is the same, and it is equal to the EMF of the battery. Therefore the potential difference here is equal to V, is equal to the EMF of the battery. So here also it is V, second resistance also it is V, and third resistance also it is V. So potential difference is same, and current is divided. Potential difference is same and current is divided. Since the potential difference is same, so same potential difference V is equal to I1 into R1, because potential difference is current times the resistance. V is equal to I1 is equal to I1 into R1 is equal to I2 into R2, because V is same, is equal to I3 into R3, because the product, because potential is the product of current and resistance, and potential is same across all the three resistances. Therefore I1 R1 equal to I2 R2 is equal to I3 into R3. It means if the resistance is increased, if from the three resistance, the resistance which have the highest value of the resistance, in that resistance current will be minimum. So if current resistance is more, current will be less in the resistance, in the resistance. So least current will be in the resistance which have the maximum value of the uh, uh, resistance in the series combination, in the parallel combination. And resistance R equivalent, we have to find the R equivalent. So here R equivalent will be equal to, we have 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So this is the formula for the equivalent resistance in the parallel combination. 1 by R1 plus 1 by R2 plus 1 by R3 is equal to 1 by R equivalent. So we will take the LCM.